Okay, so what we completed up to this, the thing is, what is ANN? So ANN is nothing but an artificial neural network. And what is our task? We want to just mimic the human mind. Okay, we want to just mimic a human brain. Okay, not the human mind, it's a human brain. So inside the human brain, there are lots of neurons. So we want to just know how that neuron actually works. So we learned that internally in neuron, there are two things. The first thing is actually integration function. Another one is nothing but an actually activation function. Not in human brain, not in human brain, but human brain actually works like that. There is some like integration function type of thing which actually collects all the input, and according to that input, one function might be there which actually takes an decision what to do. So we divide that thing in a actually integration function and activation function. So what is the task of the integration function? As you can see here, I have x1 to xm inputs, and here we have w1 to wm weight. So as per the
सर स्क्रीन दिख नहीं रही है.
1 minute. Is it visible? Fine. So now these are x1 to xm are the inputs, and w1 to w are nothing but an weight for that. So what is the task of the integration function? So we just consider a simple integration function that is actually ximi, xiwi. What is that xiwi? It just multiply all the inputs with the respective weights and sum of them. That is the integration function. Okay, and as per that, the activation function will take a decision what to do. So that's that we completed. Now we just discuss some actually activation functions, that is actually like step function, ramp function, sigmoid function, ReLU. So we just go through that. So these are the basic functions which we will learn later. After that, we just start a perceptron algorithm. Now, what is that perceptron algorithm? So that is actually how to create a single neuron. Okay, that's an algorithm to train a neuron to take a decision, okay, for the classifier or regression purpose. So now here we just take an example. Here we have 1 minute. Yeah, fine. So here we have perceptron algorithm. So what is the algorithm? It just say you must use actually two loops. The outer loop must execute for m times, or it must run for actually for some threshold actually. Okay, threshold in the sense I mean to say up to the zero error. Okay, so just check repeat until, let I just highlight that, repeat until the error is less than a threshold or max iteration m. So it's up to you how many times you want to execute the outer loop. What about the inner loop? So inner loop will work with all the features. Okay, so we just discussed this algorithm, and this algorithm is just used to improve the weighted vector. It is just used to improve the weight vector. And according to that, we want to improve the weight vector in the sense I want to just decrease the error rate, but I do not want to deal with the errors. Okay, I do not want to actually improve my model. I want to just improve the weight vector. So that is that. So this is the formula wn plus 1 is equals to wn plus eta. That's the constant, and the value of this eta must be actually between 0 and 1. What about this ti minus yi? So yi is actually a current output and ti is actual output. So this is the actual value, this is the predicted value. Subtraction will just return an actual error rate. And these are nothing but an actually like a feature vector. This is actually nothing but a feature vector. So that's that. And as on the base of this algorithm, we have an actual example. So finally, like as in this example, we just say, okay, now this is the outcome. This line is nothing but an like a single neuron outcome, or it's our model, which is just used to separate linearly separable data sets. So in this example, I have to red cross to blue cross. So this model just separate them nicely. So that's that. And after that, we discuss one thing, that is decision boundary for a single neuron. So what is the decision boundaries of a single neuron? That means what's the expected outcome of the single neuron? What is the expected outcome of the single neuron? So guys, as we know, finally, in a neuron, we will have two functions. The first one is actually integration function. Second one is nothing but an activation function. Integration function and activation function. And we just realize one thing, oh, up to this, we just consider only x1 to xm inputs and w1 to wm weight for those inputs. But after that, we just realize one thing, oh, maybe it's our input having a bias term. So how to deal with this bias term? How to deal with this bias term? So in last session, we just like calculate something, and we are right now on a decision, like we have to just apply the same function, same integration function we have to use, but we have to just start with I equals to 1 to m plus 1. Now what is that m? M is number of features, so we have to go with m plus 1. Okay, so we have to just use we have to create a vector, weight vector we have to create with m plus 1 values. But guys, what's the problem? The problem is we have only actually like m features. Then how to go with x m plus 1? How to find the term x plus how to find out the x m plus 1 term, m plus 1 x theta, how to find out that term? Okay, हमारे पास सिर्फ x I features मतलब xm features है. Then how to find out m plus 1 feature? So what we will do, that feature value let me consider. Okay, we will just put a 1. Just find out the generalized formula, that's that. And finally, after that we realize, okay, now this integration function just okay, it's just give us a line, that's it. As use, like consider we have two input features, so w1 x1 plus w2 x2. I have two features, so two weight values, w1 and w2. Just multiply them, because our integration function is wixi. So w1 x1 plus w2 x2. And if you will not consider the bias term in this integration function, then you have to write down equals to theta. Okay, either you can just consider this bias term. This is the bias term. Either you have to consider this bias term in a weight matrix, or sorry, in a weighted in an integration function. Otherwise, you have to just consider it separately. So that's that. After that, we realize, oh, the answer is actually nothing but in single line. That's that. It is just used to separate the things. So that's how to work with the single neuron. But after that, we realize one thing: if we have this type of data set, consider this is my data set. If I have this type of data set, consider that's nothing but an XOR type of thing. Okay, just recall our electronics knowledge or binary system knowledge. Just recall that. So XOR in the sense, if both the inputs are 0 or both the inputs are 1, then output is 0. Both inputs are 0 or both the inputs are 1, then output is 0. If either of the input is 0, either of the input is 1, output is 1. Okay, so that's that. And we just try to like train the system. Otherwise, we just try to like inform our model to just predict the outcome. So perceptron, otherwise single neuron. Perceptron is an algorithm to just create a neuron. So single neuron is not enough to like classify or to solve this problem. The outcome will be like this. ये हम लोगों ने डिस्कस किया था या नहीं किया guys? ये डिस्कशन हो चुका है कि बाकी है? This is in boundary of a single neuron. विजय सर, मौलिक सर.
तो शायद बाकी था, याद नहीं है पूरी तरह.
फाइन, ओके, नो प्रॉब्लम. सो गाइस, जनरली हमारा ये सिंगल न्यूरॉन है. हम लोग जनरली किस तरीके से वर्क करते हैं? अब न्यूरॉन को इन फ्यूचर जो भी हम लोग लाइक डिजाइन पार्ट या कोई भी ग्राफ या कुछ भी ड्रॉ करेंगे, उसमें न्यूरॉन को हम सर्कल से रिप्रेजेंट करेंगे, एंड जहां पे इनपुट लेयर है उसको हम रेक्टेंगल से रिप्रेजेंट करेंगे. सो कंसीडर इन दिस आई हैव टू इनपुट्स, दैट इज एक्चुअली x1 and x2, and this is the output. This is the actual output. So what's our integration function? Integration function just say like sigma of wixi, sigma wixi. So दो feature है तो दो w's बनेंगे, w1 x1. So it will be like this: y equal to w1 x1 plus w2 x2. What is that y? It's actually predicted value. Okay, ये मुझे prediction चाहिए, and we just consider we will have a bias also. इसके अंदर bias value b होगी, मतलब plus c plus theta minus theta, something like that. But what I did, मैंने यहाँ पे function लिखा है. Function मतलब bias नहीं लिखोगे तो चलेगा, उसमें से variable से लिखेगा. So w1 x1 plus w2 x2. So let me just pass both this w1 the x1 x2 and w1 w2 to this neuron. इस neuron को pass on करते हैं. So now what will happen? आप खुद से हम लोगों ने जो previously example लिया था, just follow this steps. Okay, just follow these steps. जैसे eta की कोई वैल्यू कंसीडर करें, w को कोई स्टार्टिंग वैल्यू आप खुद से कंसीडर करें, and just solve this, try to solve this example. Okay, what you will get this type of line. आपको ऐसे कुछ line मिलेगा. This is actually my model. This is my model that is actually represented by single perceptron algorithm. मे भी हो सकता है कि यहाँ पे ऐसे भी लाइन जनरेट हो या ऐसे भी लाइन जनरेट हो सकता है, इस तरीके से भी आउटपुट आ सकता है. इट डिपेंड्स कौन सा वेट आपने स्टार्टिंग में सेलेक्ट किया. बट थिंग इज स्टिल हम लोगों ने जो यहाँ पे लाइन प्रेडिक्ट की, इस एग्जांपल में जो लाइन हम लोग को यहाँ पे प्रेडिक्शन में मिला हुआ है, that's not actually a line which actually classifies the outcome outcome actually perfectly. So just check करें, ये gray symbol, that's fine, वो gray region में है. Okay, black, that is not a black region. ये जो मेरा gray region था उसके अंदर black dots classify हुआ है. ये जो white part था उसके अंदर black आया, जबकि वहां पे सिर्फ gray आने चाहिए थे. 50% perfectly classify हुआ और 50% wrongly classify. How to deal with this situation? मतलब मेरे पास डेटा ऐसा था जो linearly separable नहीं था. Okay, otherwise just recall that thing. हमारे पास तो रंगोली टाइप का डिजाइन है. आई थिंक हम लोग ये डिस्कस कर चुके हैं. Okay, रंगोली टाइप का डिजाइन है. Outer one is a green points and inner one is nothing but an actually red points. Red points I just draw. Now let I just draw the green points. So here I have some green points I have. Okay, मेरे पास कुछ green points भी है. I have some green points also over here. Okay, so now how to deal with this data set? How to deal with this data set? So single neuron is not enough to work with this. So what to do? So this problem we faced in SVM algorithm also. SVM में भी हमारे पास जब non-linearly separable data set था, so single SVM, otherwise normal line, हम लोगों ने उसमें function use किया था, that is line. So SVM with line, it's not enough to deal with this. Then what's the solution? We have to just change that function. Either tangent function we can use, otherwise another function is like RBF function we can use. ऐसा कुछ हम लोगों ने उसके functions change किया. For function in the sense algorithm. So how to deal with this? Otherwise we can do one thing. कि हम लोग stacking algorithm use करें. That's nothing but an ensemble modeling. तो हम लोग पहले 3-4 SVMs develop करते हैं और एक उस 4 SVM के ऊपर हम लोग once again एक SVM develop करते हैं. अगर इस 5 decision tree develop करते हैं और 5 decision tree के ऊपर एक SVM रखते हैं. So that's nothing but a stacking. That is actually known as like ensemble modeling. So we have two options to deal with the non-linear data set. So how neuron will work? So guys, let me discuss that. How to deal with the non-linear data set. How to deal with the non-linear data set by using actually otherwise in neuron actually. Okay, in short, train the neuron, use the perceptron algorithm to deal with the non-linear data set. So that's our main point of today's session. So guys, as we know, in SVM, we discussed two things. The first thing, either we can change the function, or another thing is either we can use the ensemble modeling, in the sense more than one SVMs we can use. Otherwise, on a first layer we can just use more than one decision trees. On that layer we can just put the SVM. So that's nothing but in sequential modeling. Otherwise, we can say that's nothing but in stacking. So we can use ensemble modeling. In short, more than one SVMs we can combine, more than one different models we can combine, and just try to deal with the non-linear data set, separately non-linear data set. In neuron also, in perceptron algorithm, or in the sense in ANN also, we have two options. Either we can just change the integration function. That's the first option. That is the first option. We can just deal with the integration function. Otherwise, we can just go with multi-layered perceptrons. Otherwise, we can just deal with the multi-layered perceptrons. In the sense that is nothing but an similar to ensemble modeling. Okay, just use more than one neuron. Okay, just use more than one neurons. Here I just write on perceptrons. What is that perceptron? That is an algorithm to train the neuron. So two options we have. So first thing, let me just learn one by one. So first thing is changing an integration functions. So what was the integration function? We have an integration function that is actually sigma of WIGI. Okay, हम लोग ऐसा कुछ करते थे, sigma WI, not the GI, that is XI. So what is that X? That is nothing but an actually feature value. What is W? That's nothing but an weight vector. उनका multiplication करते थे, that's nothing but an integration function. So we can just change that thing. So here I just use WI XI square minus theta. Okay, we can just go with this. WI XI square minus theta. That's the first option. What is that theta? That's nothing but an bias term. So that's the first option we can do with. We can deal with this thing. Otherwise हम लोग ऐसा कुछ integration function use करें. हम लोग क्यों change कर रहे हैं? Because मेरा data set non-linearly, otherwise linearly separable नहीं है. It's a non-linear data set. So we can just change the integration function. Guys, इसको याद रखिएगा. हम लोग practically देखेंगे. हम लोग TensorFlow, Playground TensorFlow करके एक website है. We will just use the deal with the non-linear data set over there. Graphically वहाँ पे बहुत अच्छा हम लोगों ने represent किया हुआ है. तो उसके साथ डील करने के लिए पहले हम लीनियर फंक्शन यूज करेंगे. सॉरी, वी विल जस्ट यूज इंटीग्रेशन फंक्शन एंड सिंगल हम लोग परसेप्ट्रॉन यूज करेंगे उसके साथ डील करने के लिए. परसेप्ट्रॉन और न्यूरॉन दोनों को भी सेम मानिएगा. परसेप्ट्रॉन इज यूज टू ट्रेन द न्यूरॉन, इट्स एन एल्गोरिदम. ओके, न्यूरॉन इज एन एक्चुअली टर्म, जो अपना मॉडल बन रहा है उसको हम न्यूरॉन बोलते हैं. बट जस्ट अभी दोनों को सेम मान के चलिएगा. ओके, कहीं पे भी ऊपर नीचे हो तो न्यूरॉन एंड परसेप्ट्रॉन दोनों वाइस एंड वर्सा यूज होंगे. सो नाउ मैं बात कर रहा था कि हमारे पास प्लेग्राउंड टेंसरफ्लो करके एक वेबसाइट है, प्लेग्राउंड टेंसरफ्लो, जहाँ पे जावास्क्रिप्ट में उन लोगों ने काफी अच्छा खासा बना के दिया हुआ है. दैट मींस लाइक इट्स क्वाइट गुड वेबसाइट एक्चुअली, जहाँ पे आप लोग आपको कुछ प्रीसेट दिए हुए डेटा सेट के. ओके, और हम लोग को ऑप्शंस दिया है कि यू कैन जस्ट यूज एक्चुअली आइदर ऑफ द इंटीग्रेशन फंक्शन, यू कैन जस्ट यूज, यू कैन जस्ट चेंज द नंबर ऑफ लाइक न्यूरॉन्स, यू कैन जस्ट चेंज एंड यू कैन जस्ट सी द आउटकम. ओके, आप एरर रेट को मॉनिटर कर सकते हो, आप आउटकम को मॉनिटर कर सकते हो. दैट्स दैट. Okay, so and there is a thread, so after one by one, after each and every seconds वो अपने आप को change करता रहता है. In the sense वो improve करने की try करता है, because it uses the looping actually, outer loop and inner loop. So अपने आप वो error rate को change कर रहा है. That is actually quite good visualization in that website. It's quite there is quite good visualization. Okay, so हम लोग को easily पता चलेगा हाँ integration function change करने भी ये outcome आ रहा है, ये हम लोग को success ratio मिल रहा है. अगर हम लोग like multiple neurons use कर रहे हैं, then this is the outcome. So there are two things. अगर हमारे पास perfectly output नहीं आ रहा, we can do one thing. Either हम लोग integration function change करें, so that's the first thing. That is actually quadratic function we can use, even though we can just use a spherical function we can just use. So you can just say that that is nothing but an RBF type of thing in SVM. This is nothing but a polynomial of SVM. That is equivalent to polynomial of SVM. Okay, so consider ये हमारा एक example हम वापस लेते हैं. So this is the data set. It is a cow shaped data set. Just check. It is a cow shaped data set. Okay, and इसको मुझे separate करना है. I want to separate them. Then how to separate them? So ये जो तीन dot है, these are the light dots. Okay, so this is the line. This is the line which is just used to actually separate them. Okay, so हम लोग ने SVM में जो मैं algorithm बोल रहा था, it's nothing but in kernel tricks. तो kernel tricks हम लोगों ने discuss की थी. Here we can just go with actually integration function. Kernel trick and integration functions are almost similar. Almost similar. Huh? So you can just change the like integration function and we can just improve the outcome. That's the first option. Another function is we can just introduce more than one actually neurons. But before that, let me just discuss how the multi-layer neurons or multi-layer perceptron look like. Okay, multi-layer perceptrons actually known as MLPs. Multi-layered perceptrons actually known as MLPs. So firstly, let me just check this one, how it looks like. तो जैसे ह्यूमन ब्रेन में किस तरीके से कामकाज होता है कि हियर वी हैव अ इनपुट लेयर एंड हियर सम एक्चुअली लॉजिकल एंड लाइक we cannot say it's a logical and computational unit, but the thing is वहाँ पे actually decision लिया जाता है. Here we have an outcome. Okay, here we have an outcome. So here we are doing the same thing. Up to this हम लोग क्या करते थे? एक बार इस डायग्राम पे वापस आते हैं. Up to this हम लोग क्या करते थे? This is my input layer. This is my input layer. This is my neuron. You can say that that is nothing but a perceptron. This is my perceptron. और हम लोग इनपुट लेयर के थ्रू इसमें डेटा देते थे and it just return an outcome. Just check. This is my outcome. That is y. That is y. Okay, एक आउटकम मुझे मिल रहा था. It's a binary classifier. You can say that it's two outcomes, 0 and 1, either yes and no. Okay, आपके पास दो आउटकम, y1 and y2. You have two outcomes. That's that. So now in a similar way, अगर मेरे पास ये मेरा input layer है, this is my input layer. In short, this is nothing but a features. All the features I will include from here. And up to this हम लोग एक ही न्यूरॉन यूज करते थे. But what I am doing, मैं मल्टीपल न्यूरॉन्स यूज करूंगा, मतलब मल्टीपल परसेप्ट्रॉन्स यूज करूंगा. और उसके भी बहुत सारे लेयर्स रखेंगे, बहुत सारे लेयर्स बना देंगे. And here we have actually y1 to yn, that is nothing but an output layer. So why here y1 to yn? Just recall the iris data set. In iris data set there are actually three outcomes, three class levels are there. Okay, so like तीन अलग अलग फ्लावर्स के हम लोग को आउटपुट मिल रहे हैं. So in that case here we have actually y1 y2 y3. और काफी टाइम्स मान लो मेरे पास 10 डिफरेंट आउटकम्स होते तो y1 to y10. अगर आपके पास दो आउटकम होते तो y1 to y2. So that is actually depends number of outcome. So like output layer number of outcome के ऊपर डिपेंड करता है, input layer number of features पे डिपेंड करता है. Do not forget that bias. Okay, तो अगर आपके पास m features है, then you have to input x. You have to just input m plus 1 things you have to input because bias को deal करना है आपने. What about this hidden layer? So hidden layers are nothing but an actually perceptron layers. Okay, so हम लोग यहाँ एक से ज्यादा perceptron सबसे पहले include करने वाले. So first layer में कितने perceptrons होंगे guys मेरे पास? First layer में मेरे पास जितने input उतने perceptrons. And guys be careful. एक इनपुट से सभी परसेप्ट्रॉन पे डेटा जा रहा है। जस्ट चेक, ये जो मेरा एक इनपुट था, मेरे पास 3 परसेप्ट्रॉन है, 1 2 एंड 3। मेरे पास 3 परसेप्ट्रॉन्स है, 3 न्यूरॉन्स है, तो तीनों में यहाँ से डेटा पास, सेकंड में से भी तीनों में डेटा पास होगा, थर्ड में से भी तीनों में डेटा पास होगा। ओके, सो दैट्स माय हिडन लेयर, that's my hidden layer. Now what this hidden layer will do, it just like if you have more than one layers, then this hidden layer will just forward the outcome to the next hidden layer, that will forward the data to the next hidden layer, that will forward the data to the next hidden layer. So if you have more than one actually hidden layers, that is actually known as deep learning. That is actually known as deep learning. That is known as, okay, so if you have more than one actually deep neurons or hidden layers, then that is actually known as deep learning. That we will learn like in later on. But now the thing is, that is nothing but an actually multi-layered perceptrons. That's quite famous thing actually. Is it done? So that is something like हम लोग दो चीजें कर सकते हैं, हमारा आउटपुट या हमारी एक्यूरेसी इंप्रूव करने के लिए या नॉन लीनियर डेटा सेट के साथ डील करने के लिए हम लोग दो चीज कर सकते हैं. The first thing we can just do, that is actually change the integration function. Second thing, we can just introduce more than one layer.